All right, today is the day, and we're back in the studio looking at building the muffler today. And if you've been following this series, you may remember a previous video where we built the exhaust system from the turbochargers back to the catalytic converters. Well, in that episode, I discussed a little bit about the problem I had with buying some existing mufflers that would actually fit in this thing. We've got a really low profile in the tail where the muffler sits, and the mufflers that I had just are not going to fit in that position. So I've ended up having to build my own muffler. And things like this are always good and bad. Of course, the bad is that it took so long, probably between 20 and 25 hours of actual hands-on building time, not counting time of buying some parts and getting things together and setting things up in the shop. So anyway, it would be quite expensive if I had to pay for the labor on that. Of course, this whole project is just a child of labor rather than anything else. So, without further ado, let's go take a look and see how that muffler was built. So to start with, we're going to take some fairly heavy gauge stainless steel sheet to the plasma cutter. First piece I'm going to cut is just a rectangular piece that's going to be the main box of this muffler. Now I've also got a press that I've made an attachment for it. There's a cast piece with a small radius in it, and then a bar with a radius on the top. Squared in the machine. And we're going to put some bends in this with, like I said, with the radius rather than sharp edges. So here's the attachment I'm talking about. Squaring it up as best I can. Taking down to about 35 degrees on two of the bends, 45 on one and 90 on the other. And you'll see that finished construction here in just a moment, but taking through these bends. Of course, the key with making these nice round bends is makes it much smoother to handle and looks much nicer. I won't show you all the bends here, but this is the process I use to bend a lot of sheet metal with radiuses. I have a small break for other little things. That leaves me with one seam. I'm just going to tack it right now as we assemble most of this. Just tack welds until we're ready to verify that everything's correct. And once I have that box built, I can lay out the ends, and there's going to be, of course, two ends and a center panel that's going to divide the muffler into two pieces for each side, each bank of muffler out of each of the turbos. The one center panel is going to have a bunch of little tabs on it that I can bend that'll keep it aligned, and it'll stand by itself inside the muffler. Now anybody that has ever had to cut sheet metal of this gauge will know what a plasma cutter is worth its money in gold. Of course, trying to get nice straight lines on the panel itself to fit tightly in the muffler box with these tabs, just freehanding the tabs because they're just in there to align it and for a little welding surface. Once I get all these panels cut out, the ends are going to have the pipe running through them. It's going to be the input, and then it's going to go through this 180 degree turn and then out, make another 90. And I need these holes in these end panels to be perfectly lined up for this 180 degree bend. So once that holes are cut out, the 180 bend needs to line up with those perfectly. So marking them out, and then I'm taking a set of calipers and finding center, using the method where you just make an arc off of 4 quadrants of your circle, and then each of the intersections of those arcs, if you draw a line through the center of those, you will get dead center. In just a moment, I'll show you with a pen what I'm talking about by drawing the arcs off of the quadrants. And this is pretty accurate even if you aren't dead center on the quadrant connections on those. So there's the arcs, and they'll connect to make center. And then take it out, cut my holes out. Now my hole saw was slightly under the 2 inches of the pipe, which is good because I wanted these to fit extremely tight. So cut them out with the hole saw and then took it and filed them to shape. Now that 180-degree bend, I'm going to put little notches in it, about 3/4 to 1 inch notch every inch or so. And then along the sides and underneath as well. So all around that 180-degree bend. And then taking it and just pounding them down to open them up. Chisel to get it started, and then a center punch to drive in, creating kind of a little catch, as you might say. As the exhaust air comes through, it's going to hit that little catch and force it into the muffler cavity. So here's one of the 180-degree bends, finished with those little divots that I talked about. Now we're ready, got all the parts ready, we're going to start assembling. And this is the center panel I was talking about, those tabs. Going to bend them to 90 degrees so that they will help aid in sliding it in and holding in position while I weld it. You also notice there's a single hole in the middle of the center panel. This is a pressure release between the two sides of the muffler. Just a little trick to equalize the pressure and smooth out the sound so you don't get one side if you have a little variation that seems to produce a little more volume. So these stand off of the hole just a little bit, and we are going to stuff a little stainless steel mesh in there to muffle some of the sound as it travels through. And I'll show you this mesh a little bit better as we go on here. Like I said, there's little panels on each side of that hole. Stuff this stainless steel packing in there. And once it's sitting in the middle of that hole, there's little grooves here cut so that we can take a chisel, bend those tabs over. It'll hold that mesh in place so that it doesn't get blown out. Okay, so once those little tabs are bent over, we're ready to install this thing into the box. Knock it in. I've got, not shown is, did a measurement, got some pencil marks inside the box so we know where center is. Once that panel's in there, just a matter of welding the tabs first to hold it in place and tacking it in there. And then moving on to our end plates. You'll see here we already have the 180-degree bends inserted through the holes. Well, one side is inserted through the hole. The other one, the 90-degree bend comes through the panel, so that weld is inside the box. Just easier that way so that another weld doesn't have to be shown on the outside. It's internal. Now once those bends are already on their panels, it's a matter of putting the packing, the muffling episode of this. And this is Scotch-Brite stainless steel scouring pads. Just found them at this grocery store. Expand them out and wrapping them around the 180-degree bend. I've got little stainless steel wires that I've made into little C-clips. So as you stretch this stainless steel mesh around, I'm just hooking them temporarily with these little C-clips. Now this mesh is I don't know how to explain, is a highly aerated. In other words, the air is going to be able to pass into this mesh very easily rather than going straight to fiberglass. But there will be a second layer of fiberglass. And I guess I'll try to explain how this works. If you were to throw a rock into a pond, a large rock, it's going to create a very large ripple. And we'll just compare that to a large, harsh muffler sound. But if you were also to throw a handful of smaller pebbles into the water, it would create multiple ripples, which would counteract the big ripple and knock it down faster than just a smaller stone. So what we're trying to do is create a method for some of the sound waves when they travel into the muffler to break into smaller waves. So multiple smaller waves that are going to resonate in the chamber, come back to the muffler and try to cancel out the larger, harsher sounds coming through the 2.5-inch pipe. So Our stainless steel mesh is on. Now we're going to wrap it with fiberglass. Got this stainless steel wire that we're going to tie it on temporarily, and then we're going to do a tight bind with that wire. So just creating a type of little, like a little lasso loop to cinch it on one end, and then I'll just go ahead and do a spiral wind with this wire around the fiberglass and the stainless steel mesh to hold it in place. Now I contemplated this about how this is going to work. Of course, we want this muffler to last a good 20 years. This is a pretty heavy gauge stainless steel wire, so I don't think we're going to have a rust problem unless, of course, I start the car up and turn it off and let it condense moisture in the muffler. One more reason to treat your car right, to always warm it up. Otherwise, this wire should hold this in place for quite a few years. I believe the fiberglass would probably break down before the wire will. Yes, another thing, prototype. I guess the muffler's a prototype as well. So kind of a trade-off. You don't want to pack it too tight. You want some air to pass through it. You don't want to leave it too loose so that it flops around, and movement, of course, is going to break things down a lot faster. But once these things are all tied up and ready to go, we're going to insert them back into the box. Coming around the other side of that fiberglass wrap. Kind of hard on these narrations to know when to try to explain more details when there isn't nothing I can think about until we get to the next step where you're actually seeing something. But learning as we go with this narration thing. Of course, I'm not a person of a lot of words, so it's hard for me to just rattle on about anything when we're doing this, but so when those two wires meet in the center, you're going to tie them together, put a good twist in them so that they won't fall apart. And it is ready. You can insert it into the box. Now these end plates are created with just about a 1/16 of an inch overhang. Gives me a little bit of metal to pull back in the weld. First, we're just going to go ahead and tack it all up so we can get it nice and tight. And once it's all tacked all the way around, of course, it's a matter of starting the weld. And even though I would weld about 3 inches at a time, still got some warpage in that metal. One reason I chose the really heavy gauge is the welding. I hate having to weld super thin gauge metal and have it burn through little holes. But the thicker you go, the less warpage you have, so this was kind of right on the edge. And these are my final welds ready for fitment. So the way this is going to work is we have the catalytic converters feeding into that top 180-degree bend. And I've got mechanical clamp connections for these things. Centering it up, making sure it's a dead center on the frame. Like I said, the mechanical connectors between these pipes are stainless steel pieces that weld in. They fit beautifully. The only thing is that they will move a little bit, and that's good because they're going to allow me to adjust everything. So as the clamps are on, I can tack weld it and make sure everything is exactly in place. And then hanging from the top off the main member of that subframe is going to be one of the hangers. So there'll be one that holds it out off a pretty stiff bar, and then 2 hangers in the back. So 3 hangers plus the hangers off of the top muffler, hold the catalytic converter, should be pretty rigid. Like I said, there is a little bit of play in the fit of the pipe going into these connectors, so makes it so I can get nice tight connections in the trial fit. Once that's tacked, we're ready to try for the bottom fit. Now I have to make a little pie cut in the exhaust exit here for the tail pieces. That pie cut goes in, and that puts my tail pieces exactly where I want them. So once I have everything tacked in place, now it's time to take the whole thing off and take it to the bench and do all the final welding. Undo all my mechanical clamps, and then have to try to undo all the rubber fittings. Of course, good and bad that they're nice and tight, those rubber fittings, so if we can squeeze it off of the steel rod hanger, we'll be good. I said everything's done now, just a matter of going through and do all my final welds. And once I have this thing all welded up, I'm going to skip a step that you're not going to see, and that is me going through and kind of cleaning up all the welds. And because I want to coat it with this ceramic coating, this is Cerakote. It's a titanium color. And now that it's the next day, time to try it all fit back together. You'll notice also as part of the masking that I did of these parts, I threw the Jarvie name on there. And so you look through and see the polished stainless in the name, and then the rest of it's got that titanium ceramic coating. Hook those rubber donuts back up. Put my catalytic converters back on. Of course, we always want to see your finished work. Although this, of course, like everything on this engine and the subframe here, is just temporary. Everything will come apart before the final assembly in the end. Everything's hanging just right on the rubber suspenders. Now putting those mechanical clamps, holding everything back in place. Another reason to do this assembly is I know exactly where the clamps are at. They're on the muffler. Tighten everything up, just make sure everything fits good. And there it is. There you have it. That's how you build a muffler for your very own supercar. Now, I had a discussion with a subscriber about the length of time it takes to build a project like this from scratch. And there's a lot of things that a person doesn't take into consideration when they're even thinking about something like this. First off, that halfway through there, you're going to wish that you had started just restoring something that already existed, because all the parts are there. And if they're not there, they're somewhere available and you can get them. Or if you have to build a part, it's one or two little things just to replace something that just can't be found. In the case of this car, almost everything is built from scratch. Now, if you had the resources to actually design and completely build this thing in a 3D world and do all the engineering and the calculating on a computer platform, that also means that you are just going to take those files and send it off to somebody to fabricate the parts, as in the muffler. It would have been a matter of designing what you want, sending off to maybe even a person that actually does sound tuning, a studio where they will run the engine in a sound booth and work on getting the tone just right. And then you would have shipped the plans off to fabricator that would work in titanium, and the muffler would have cost you somewhere between $25,000 and $30,000. Well, that's our budget for the entire vehicle, so of course that's not going to work, is it? So here it is, as it sits. The description of what's going to go on it now is the rear panel bumper sits here. There's a bulge here that will cover this. Right now there's no absolute knowledge of that it will clear, but that's something we can modify, and I believe it will. It should come out and give me about 3 inches of clearance around it. The diffuser, the muffler itself, tailpipe will be sticking out in the middle of the diffuser and the slipstream of the diffuser. And then once we get those parts fitted and know they're going to work, we will disassemble this whole thing. Frame will be set up, be powder coated, and ready to reassemble it, put it back in the vehicle. So, hope you enjoyed this video. Like I said, something a little different from all the lamination we've been seeing on the body parts. A little bit of fabrication in the metal, some more of that coming in suspension pieces real soon. But we'll also be back and forth into the lamination, creating those body parts. That tub's coming along. We'll show you that pretty soon. I'm also going to link a video right here that shows you the connection to the video right before this, showing the fabrication of the exhaust system from the turbos back to here. But anyway, thanks for stopping by, and I hope you come back and see us again.